Welcome to another episode of Tech Talk, where we dive into the latest and greatest in technology and innovation. I'm excited to explore a fascinating topic today, the groundbreaking research around MASt3R, which stands for Grounding Image Matching in 3D. So what exactly is MASt3R, and why should we care? Let's kick things off with a little context. Imagine you're looking for a specific spot in a bustling city. You pull out your phone, snap a picture of the place, and then, voila, you get instant navigation and details about that very location. This is essentially the goal of MASt3R. It aims to enhance visual localization by effectively linking images to their corresponding 3D counterparts. The key players in this project, Vincent Leroy, Johan Caban, and Jerome Rivaux, are pushing the boundaries of how we understand and utilize image data in three-dimensional environments. One of the impressive aspects of MASt3R is its ability to leverage what's called asymmetric MASt3R models. You might be asking, what does asymmetric refer to in this context? It means that the model has different pathways for analyzing image features, optimizing the process, and making it more accurate in matching images to spatial points in 3D space. Now let's think practically. Why is this important? Well, with advancements in augmented reality and geographical mapping, accurate visual localization can transform industries ranging from tourism, where you might see real-time overlays of historical data on landmarks, to autonomous driving, where cars need to navigate and interact with their surroundings effectively. But how does one even begin utilizing MASt3R? The setup can seem daunting at first glance. For instance, the installation involves cloning the repository from GitHub and creating a specific environment. It's like setting up a DIY project, where each step builds toward the final product. You might feel a bit overwhelmed, but there's an interactive demo to explore, essentially a sandbox where users can visualize and understand how the model functions. Speaking of demos, there's an interactive experience available via Hugging Face. It offers an engaging platform to test the MASt3R's capabilities in real time. Think of it as trying on a product before making a purchase. You can reconstruct larger scenes or test how well it integrates with different datasets. And what datasets are we talking about? The research encompasses various datasets, including CO3DV2 and blended MVS, which provide the training ground for these algorithms. But let's not forget about the ethical side of dataset usage. Researchers have to be conscientious about licensing, especially since many of these datasets are subject to stringent copyrights. Now, some of you might be curious about the training process itself. It's pretty fascinating how researchers tweak hyperparameters, like learning rates and batch sizes, similar to adjusting a recipe to get the perfect dish. This fine-tuning is crucial for developing effective AI models. As we wrap up this exploration of MASt3R and its impressive implications in 3D visual localization, I have to ask, how do you see this technology impacting your life? Do you think in the near future we'll have tools that make navigating our environments as easy as snapping a selfie? Thanks for joining me today on Tech Talk. Stay tuned for our next episode, where we'll explore even more revolutionary technologies shaping our world.